Okay. Oh, I still need to get packets to some people. So do you have these packets? Monday and Tuesday and yesterday, you also had work to do. We started a new unit. Hopefully we viewed those videos about some, I can't get this to straighten out. There we go. There we go. About similar figure. This is our unit 7. So I'm just going to kind of go through and talk about each section on this warm up, and then I'm going to give you a chance to try it out yourself before we go over it. And you also had homework yesterday on similar figures that got a little more in depth than this, and we'll make sure to spend some time maybe doing just a few of those, not all of them, because there's quite a few. So what we talked about Monday, Tuesday, similar figures, in order for them to be similar, it means that the sides are proportional. Okay, that they reduce to the same ratio. So when they're not the same size, you can see that like on the first one, that top shape is larger than the bottom shape. It's actually almost like a dilation where you take something and it expands or contracts, and you're keeping the same angles, it's the same shape, and it's proportionally, all the sides are growing or decreasing at the same, in the same ratio or in proportion. So to state if the polygons are similar or not, we need to see, are the sides proportional? So when I look at this diagram, I'm seeing 15 would correspond to what side in this figure? To 10. So does 15 to 10, and I'm going to leave that there for a minute, is that proportional to, what does 24 correspond to? 16. And the reason that I don't have to do all 4 sides here, if it was a shape where all 4 sides were different, then I would look at all 4 sides. But this is clearly a parallelogram where my opposite sides are congruent. So I don't need to look at 15 to 10 again, 24 to 16 again. It's going to be the same ratio. So for this particular example, and same here, I only need to look at 2 sides because the other 2 are the same. So what is 15 tenths reduced to, or what can I divide both 15 and 10 by? 5, which reduces it to 3 halves, and 24 sixteenths I can divide both by 8, and it reduces to 3 halves. Because this is the same ratio, that tells me that they are proportional. So I can say, yes, they are similar. If I looked at my reduced ratio and it was 2 different ratios, then I would say, no, they are not similar. Okay, so on a question like this where I'm stating if they are similar, that's what I'm looking for. And it's a yes or no question. Okay. On 3 and 4, the directions are different. It tells me that the polygons are similar. The polygons in each pair, they are similar. So I already know that they are proportional, that they are similar figures. Find the scale factor of the smaller to the larger figure. So this is also important. I want to go from small to large figure, meaning I want to go from here to here. So even though the smaller figure is drawn second, I want to make sure that I figure out the scale going small to large. What this scale means is it's really just the reduced ratio. So on the one we did first, this would have a scale. I went large to small. So scale large to small would be 3 to 2. It's just the reduced ratio. Okay, that was large to small the way I went here. Now, in order to do this, I need 2 sides that both have numbers. So which side, for matching sides, both have numbers that I can use? 15 and 20. So I have to go with this side because they both have a numerical value. I can't use 9 because I don't have a match up here. I can't use 11.6 because I don't want to and it's a decimal, but also because there's no match here. I can't use 12 because there's no match here. I have to use the two sides that I have numbers for both, and going small to large, I would go 15 to 20, which reduces to 3 to 4. And the way we write our scale, this would be fine, I'd take it. But typically we write our ratio this way when we're talking about scale. It's a scale of 3 to 4. Okay, so you do the same thing on 4, figure out what two sides match, and then go small to large. 5 and 6 is where we're trying to find a missing side. So again, it tells us they are similar, which tells me they are proportional. And if I want to find the missing side, which is here, it had a question mark, but I'm just going to change that to X. Now, missing side X, what does it correspond to? 5. So X to 5 has to be proportional, which means equal. The ratio is going to be equal to, well, my other side is 20. What does 20 connect to? 4. 20 to 4. Okay, X to 5 has to be an equal ratio proportional to 20 to 4. So when I'm solving, and we're going to spend some more time looking at this, hey, I'm setting up my proportion, because equal ratios, that's going to give me my proportion. Before I solve, I don't want to use large numbers. First, let's reduce. What is 24 reduced to? Flip it, right? 5 over 1. So I'll leave it as 5 over 1. Okay, what do I do to solve a proportion? Cross multiply. So I'm going to cross multiply here, which, because we reduced and it happened 24 goes into 20 evenly, made it super easy for us. Gives me 1x. 5 times 5 gives me 25. We solved. Okay, for our missing side. It's a quick download. Okay, so I did 3. Now I want you to go back through this warm-up using those examples. Okay, each one is a different direction. So you got to maybe reread the directions, make sure you know what you're doing there. Okay, and then we'll talk about the other 3 problems here. I'll leave that up there for a minute. So let's look at what we have here. Now on the first one, so I purposely gave you 2. Sometimes it's a yeah, and then we can say, like I could say the scale factor. I think on the checkout yesterday, it asked you like, is it proportional? If it is, what's the scale factor? So I could have said, yes, similar, scale factor is 3 to 2. If it's not similar, there's no scale factor. They have a different scale in terms of the size. And so 20 over 20, 16 over 15, well, I know this isn't going to reduce to 1 like this one is, right? So not similar. On 4, it's just asking you for the scale factor. So comparing sides. Now I saw some of you compared all of the sides. That's fine, or all the sides you could. You looked at 12 to 8 and 15 to 10. We already knew that they were similar. So we don't have to look at multiple sides. We just need to look at one comparison. We know it'll be proportional because it told us that we were similar. It's okay, it's just a little bit extra work. Reduces to 3 to 2. Now, I will say something I didn't notice before, and I actually think everyone I looked at had 3 to 2, but maybe somebody can tell me they had it the other way around. I'm actually going to change this and write it as 2 to 3. Why am I going to write it as 2 to 3? Yeah, and I missed it too. And like, I think everybody I looked at had 3 to 2, so I didn't correct you as I went around. We want to pay attention to those things. So this would be the scale going large to small figure. This would be the scale going small to large. Like if I had started at 8 and gone to 12, it would be 2 to 3. That's my goal. 6 is definitely more challenging if we don't reduce, right? So if I tried to multiply 18 times 30, I'd have a much larger number and then forget dividing by 36 afterwards.
Yeah, 36 equals 500.
Yeah, it would not be fun at all. So always kind of take those opportunities. If I can reduce a fraction, let's reduce it, then cross multiply. Still a little bit of a larger number, right? 5 times 18 gave me 90. Divide by 6 gives us 15. Okay. So let's look. I know not everybody completed this homework yet, but yesterday, also just as a heads up, making sure we're still getting things into Google Classroom. Yesterday, I asked that instead of meeting, we do homework 32 and the checkout in here. So you should have like the 3 pages before this completed. And if you haven't done that yet, you'll want to kind of spend some time over the next few days looking at this, because I think this is really like this is the meat of the unit. This is like really where most of the problems are, is in the similar polygons. I will look at, well, I'll just kind of quickly talk through the first few, and then we'll look at a few proportions that are a little more challenging before moving on. So one thing I'll say on number 1, I'm not going to look at these decimals unless I absolutely have to. So it's asking me to decide if they're similar. I'm going to start with the sides that aren't decimals, and that's going to be enough, because if I look at 14 to 7, well, that reduces 2 to 1. And then I look at 6 to 4, that reduces to 3 halves. I don't have to look at the decimal sides, because I already see that those sides aren't proportional. Does that make sense? If those sides were proportional, I'd have to move to the decimal side. And so just to kind of talk about how you would deal, like I'd want to make sure that this was also the same ratio. So what I would do is just move however many decimal place moves you do in the top, you do in the bottom. So for example, if I had to move 2 decimals here, I'd still have to go 2 there, even if I didn't need the movement of 2. And then I would reduce from there. That's how I deal with it if you have to. But like I said, I don't have to. Like I already see these aren't the same. So I'm just going to say not similar. I'm also going to introduce a symbol to you, which was on our notes from Monday and Tuesday. Instead of having to write the word similar, this is lazy style. This is our symbol for similar. So just like that funky equal sign with the line over it is congruent, this means similar. It's kind of, yeah, I kind of have a mustache. I think of a wave, like a rolling water wave. It's very peaceful. 2, I don't have to compare all 4 sides because I have a rectangle here. So if I look at 20/12, is that going to reduce the same as 40/24? Hopefully, maybe we can even see, like the top one is half reducing the bottom one. Like I can already see that they're proportional. But just for fun, 20 and 12 by 4, so 5/3. And 40 and 24 by 8, 5/3. So I would say yes, they are similar. And if I wanted to give a scale factor, I could say 5 to 3. Going large to small, in that case, it didn't tell me to write the scale factor, so didn't have a rule to follow. 3 and 4 tells us that they're similar, and it wants me to find a scale factor going small to large. So let me just do 4. Making sure I go small to large. I can pick any side, so as long as I have both values. So I would say that 12 matches to 15, and even though this is flipped around, it's pretty obvious to me that these sides match. So if you're ever in a position where it's a funky shape and it's kind of flipped around, choose the easiest, like for you, picture-wise, what matches up. So going small to large, I would say I have 12 to 15. Or 4/5. So my scale is 4 to 5, small to large. Okay, then it gets to this section, which is definitely more involved than what we did at this is like what's at the bottom of the warm-up. So we're going to set up a proportion. We know that they're similar, and we're going to solve. But you can see that there's more going on than just the question mark or just x here. What is this x plus 5 side correspond to in the other figure? 15. This shape's been flipped around. So x plus 5 corresponds to 15. Now, one other thing, we talked about this Monday, Tuesday, that we have to be careful of is that if I went from here to here, then on the other side, I want to make sure I go from this shape to that shape again. Like I don't want to flip it around and say go 20 to 16 now, right? Because if I go 20 to 16 now I've flipped it. And this ratio is small to large, and this ratio is going to be large to small. So what should I have this equal to? What to what? 16 to 20. And then again, I don't want to, maybe you want to, I don't want to multiply 16 and 15 together, right? If I cross multiply it as is, I'd have to deal with some stuff. So I'm going to reduce this, if I can reduce it, which I can. What is 16/20ths reduced to? So you could have kept going, or you could have used it. You still would have had a little bit smaller numbers to go with. So reduces to 4/5. Now my work's a little easier, but this is the first time this group is seeing this where I have more than one term. So when I multiply this 5 and x plus 5 together, this is what we need to be careful of, is that 5 has to multiply by that entire numerator, all of x plus 5. So I'm going to put it in parentheses and eventually we'll distribute, right? Is equal to, and 15 times 4 gives me 60. Okay, and so when I have that where I have more than one term, I need to distribute, which distributing 5 through, I have 5x plus 25. Now it's just an algebra equation, right? So I just have to solve. What would I do first? Subtract 25. 5x equals 35. Equals 7. Okay. And I'd set up 6 before. I'm not going to go through that one again. Should already be submitted, but just to kind of check our work. Let's look at the next page of this homework real quick. Let's see, which one do I want to choose? Let's look at 10. We'll look at a couple of these. So, oh, I can't zoom in, so I'm on this one. So on 10 or on any of these, you'll notice 7, 8, 10, and 12 from that homework gave us a similarity statement. So just like when we have congruent triangles and we wrote the last unit, okay, that we took an assessment on before break, when we have congruent triangles, the order mattered, right? So we had to match up sides and angles perfectly. Same when we have a similarity statement. So this statement, because this is kind of a funky setup, is what's going to help me set up the correct proportion. Because I can look at it and you can see we talked about this one on Tuesday when I was with the other group. If I have UV and UK are in the same position, so UV here, UK here, that statement is telling me that those pieces match. So that 80 goes to 24, okay? Or I could have gone 24, I could go either way. What's important here, let me kind of color code my triangles. Because I went for this first match, because I went pink to green triangle, right? The way that this is drawn, same as we were talking about on the front page, when I write the other side of this proportion, I need to continue to go pink to green triangle. I can't flip it around or else it's going to mess some stuff up. Okay. So that's going to be equal to, and just double checking here, UW, let's make sure we only have this other side, so I better match, but let's make sure. UW matches with UJ. And again, I have to go pink to green because I started pink to green. I want to clarify something about that in a minute. Okay, so that would, and then I would reduce. Let me clarify what I mean by this. It's not like I have to go pink first. Because I chose pink first on this side, I have to go here. I could have written this differently. I could have done this. If I went 24 to 80, which is going green to pink, then I would have gone 33 over 9x plus 2. So there's multiple ways you could have set it up. Like I could go here to here, or I could go here to here. This proportion is just the flipped version of the first proportion. And when you cross multiply, look, 80 times 33, you're going to get the same. Okay, so I'm not saying this is the only way to set it up. I'm saying that the order you go in has to match on both sides. Okay, so 80 24s. Oh boy, I don't know. What should we start with dividing by? 8 gives me 10 thirds. Man, that's a whole lot nicer to multiply by, huh? And then cross multiplying, what do I need to do here? With this 9x plus 2, I need to make sure I put it in parentheses. So I have 3 times 9x plus 2 equals 330. Making sure we distribute. That's why we have, when we have those multiple terms, that's why we have those parentheses, right? It's reminding us that that 3 has to multiply the whole shebang. So then I have 27x plus 6. Subtract 6. Who knows? Oh man, I'm already stressed about this division. We'll figure it out. 324.
Yeah.
Okay. Divide by 27. I don't know. Let's look at it and see how it goes. I wouldn't make you have sweat through this division on an assessment. How many times is 27 going to 32? Once. 32 subtract 27. Bring down the 4. How many times is 27 going to 54? 2. So goes in evenly, right? Phew. 12. That doesn't seem right. I guess it's right. Yeah. Okay. Okay. So, and well, do I want to confuse you with the? I guess we'll look at 9 and 11 real quick. And if you've watched the notes, I'm boring you right now. If you haven't watched the notes for Monday and Tuesday, this is all new and you're probably having like your brain's hurting right now. Okay, so it depends on how you worked on Monday and Tuesday. We've already done this, but I'm trying to make sure that I at least say it again now that you're in the building. Okay, so ones that give me the similarity statement, super important to use the similarity statement to set up my proportion. Now, 9 and 11, they don't give me a statement. And they look super weird. And what's happening on 9 and 11 is I have this large triangle and I have a smaller triangle inside of it. And the sides are still going to match up just like before. So like 21 to 35, that this side goes to the large triangle side there. That this side goes to this long side of the bigger triangle. 27 would go to 45. So really it's just 2 triangles, but they're like overlaid on top of each other. You could break them out and say, well, the small triangle is 21, 27, 3x minus 12. And the large triangle, if I do in green, has a length. Total length of this side is 35. Total length of this side on the outside is 40, 45. So another option is to just break the diagram apart if that's easier for you to see. And then I match up my sides. Okay. So like on this one, if I was solving for x, I already wrote up here that this 3x minus 12 goes to 40. By the way, can't reduce this. Like I can't reduce the 12/40ths if I wanted to, because I have more than one term up here. That's an illegal move. I can only reduce the simple ratio that's on the other side. So like if I go 21 to 35, I can reduce the 21 over 35 to what? 3/5. Okay, and then I would solve for that. I'm not going to do this one all the way through, but just so we've talked about like these funky ones and that there's stuff going on in terms of how to set that up. Let me just see. Okay. All right. So now just to kind of see where we're at, we are going to do a quick little check here. So I'm going to switch. I got to switch it this way, I guess. See if I can zoom this in. Too much. So I have some note cards for you. 2 polygons. And I want you to make sure to label them. Number 1, how would you set it up? Solve. Number 2, how would you set it up? Solve. And it's not going to count against you. I'm just going to give you the feedback tomorrow so that you know. Okay? So show your work honestly, how you would do your work. I don't care what side of the note card you use. I mean, do I care a little, but I'm going to do whatever makes you happy.
Christmas Eve, we started playing on the video.
Mm-hmm. It's Christmas time.
We sing Christmas music all the time, but
Mm-hmm.
Screw this. Can I reduce it because it could all go like 2 people on all of them?
Technically, yes, I think you could. X 4 over would be X minus 4 over 6. Is it gonna work? I don't think it
Would
will.
be 6 over 9.
Oh, you have it flipped around. That's why it's not gonna. Okay, I was like, that's not gonna work that way. Okay, so then you have 9x minus 36 equals 36. Well, I guess I could have reduced that. 9x equals 72, x equals 8. Yep, you're gonna get the same answer. I will tell you that 6 times 35 is 210. In case you run across it. Oh, I wrote it up here, but you can't see it. 6 times 35 is 210. Okay. So adding those letters, I can also say, if this is my small triangle in here, I need to add one more letter. Let's call this H. That's short length. If I'm going from small to big, what I have written up here, then I can say A to E, small triangle to big outer triangle, would be equal to, give me another one that it would be equal to.
C to F.
C to F. C to F. Or I could go down here, H to G. Okay, all cases there would work. So I have all sorts of ways that I can set up proportions when I have this embedded triangle inside this larger triangle. So let's look at a couple examples where we can use this. Now, realistically, I don't really ever have to use this one, I guess. We could just go with what we had been doing, and I'll show you that on an example here. So to solve for X and Y, we're going to use both of the situations I just showed you. So to solve for X, I'm going to use this, where I go, my sides are broken down proportionately. So to solve, let me see if I can make this a little, go. There we go. To solve for X, I know that these are broken down proportionally. Now I don't always have to go top to bottom. We can, it doesn't matter. I could also say X to 9 is 10 to 8. It doesn't really matter which side I start there, but that's broken. The way the sides are broken up will be proportional. I could say X to 9 equals 10 to 8. Or X over 9 equals 5/4. And we're going to get a fraction here. Cross multiplying, that gives me 4x equals 45. Oh my gosh, I'm not going to be able to do this thing. And x equals 45/4. Okay. But to solve for y, this is not part of a side to part of a side. Y is going, here's a small triangle inside a bigger triangle. I need to go small triangle, big triangle, that idea, to solve for y, where I say 10 to y equals, what I could use this side of my triangle is 8 to what? What would the outer length be of the big triangle? 8 to 18. Yep, adding these together. Okay, so I could go part to part. That's how I would solve for x. Or I can go small triangle to the big triangle, which, by the way, I could have also labeled this big triangle side. It would not be 9x. It would be 9 plus x. I'm adding the pieces together. So like if I wanted to, I could have used here, I could have gone 8 to 18 or 10 to, well, I wouldn't use y. 8 to 18 is 9 to 9 plus x. And I still would have been able to solve for x there. Okay, so like you can do that. It's always just write what the long length is and always go small triangle, big triangle. Up to you. So then reducing that, this is going to give me 4/9 here. Cross multiply 4y equals 90 and divide by 4. What is that going to give us? 90 divided by 4 divided by 2 is 45/2. They're both fractions, I think. Can't see it. Okay. Same idea on 8. If I wanted to solve for m, probably easiest to say that m to 12 is equal to what? 15 to 10. That's going side to side there. That's using the new idea. Don't have to use that. Could have gone small triangle to big triangle, but it's a little bit faster, especially if m was all we were trying to solve. I reduced 15/10 2m equals 36. Half of 36 is 18. But when I get to n is going from this side of the small triangle to the same side of the large triangle. I need to go small triangle to large triangle there. What could it be equal to? 15 to full length.
25.
To 25, yeah. So when I get to this bottom side, I have to go small triangle, big outer perimeter here would be 25. So 15 to 25, run over 20 equals 3/5, reducing that 15 over 25. 5n equals 60, cross multiplying. N equals 12. Last one's the easiest one. So this is what I mean by like, it's nice to know this because if I had something like this, I wouldn't go small to big. All I have are 2 parts. So I might as well just say, well, p to 12 is equal to p plus 6 to 16. I can't reduce anything there. Okay, and yes, my variable's in 2 spots. No worries, it's gonna be okay. I cross and 16p equals 12. Remember everything in parentheses times p plus 6. And we'll just have variables on both sides at first, and we'll have to deal with that and solve. 12p plus 72. And I subtract that 12p, giving me 4p. And that goes in evenly, I'll just tell you. It's 18. Okay, so certainly if I have a problem like this, a lot easier to just do part to part. We're gonna run out of time. So let's just plan on, we will finish this up next class. You don't need to finish the review for tomorrow. I'll change the due date and have it finished by Monday. But you should start it. Do what you can, kind of look it over. And then tomorrow we'll finish up, we'll talk about the review. Maybe at the end, we'll take a quick assessment. Again, it would be open notes, maybe. If not, we'll figure out a way to do that next week, okay? And then next week will be the same thing. We're starting a new unit Monday, so you gotta stay with the material.